Hello, good morning to all. So I'm here again. So on the last time we studied about standard length, standard mass and standard time. We also did a few numericals regarding conversion of units from one to another. I hope you did not have got any difficulty in doing that. And if still you have any problem, you may ask me personally also. So now what we are going to do is we are going to study about some devices which are used to measure length. So we are going to the next slide. Now girls, in this slide, we can see a red bar and we can see a ruler. We have to measure the red bar with the ruler. Now, we all have measured certain things with a ruler and we know how to measure. We'll put the beginning of the ruler on the beginning of the item, whatever it is, maybe a line, maybe a pencil, maybe any mark, and we'll see till how long it goes and we'll measure it. Now here similarly we have this red bar and this is to be measured. Now if you all can see that it is 2 centimeters completely. You know that the minimum which a ruler can measure is 1 millimeter because there are 10 equal divisions from 0 to 1 centimeter. So that means 1 millimeter can accurately be measured. Now this red bar, you can see it is 2.3 completely, 2.3 centimeters. But it is neither on 2.3 exact nor it is on 2.4 exact. It is somewhere in between. So now what we will say? What is the length of this red bar? We'll write that it is 2.3. But now we can't say it is anything in between that. That is 2.33, 2.34, 2.35. It can be anything. The second decimal place is in doubt. We can't say what is it. It can be 2.39. It can be 2.31. It can be anything. So to measure this length accurately, we have a device which measures the second decimal place accurately, and that is vernier calipers. So we are about to study vernier caliper in the next slide. So what is vernier calipers? The meaning of caliper is measuring device. And about 400 years ago, in 1631, a French mathematician, Pierre Vernier, devised a method to measure the second decimal place in length accurately. And this device was known as vernier calipers. Now in the figure we can see that there is a pink part and there is a white part. The white part is the main scale and the pink part is the vernier scale. The vernier scale slides over the main scale. Now, as the parts are mentioned here, there are 2 fixed jaws. You can see the outside jaws and you can see the inside jaws. We'll understand in later slides what is the importance of these jaws. Then we have a screw, we have the main scale readings, we have the vernier scale readings, and we have a strip T. That is also very important. So we have to see that the vernier scale slides over the main scale. That is very important. I'll show you one video also that how does it slide. That is very important for you people to understand. You have to do this in lab also practically. So before you do this, you have to understand this well. So we go to the next slide. So in the last slide, which was a video, we saw that how is the yellow part, that is the vernier scale, sliding over the black part, that is the main scale. How does it open? Then object comes in between the blue object, then it closes. How does the jaws are in contact with that object? They close it very properly, and then the measurement is taken. So now here in this picture, we can see the red part is the internal jaws, and below the white part are the outside jaws or the external jaws. And then the main scale, then the vernier scale, and this is the tail or strip. When we open it and when we close it, the object is kept here in between. So this outside jaw is used to measure any diameter or any length of any object. Like you take a coin, you place between these two jaws, bring it close so that there is no space between the object and the jaws, and then you can read the measurement. How to read the measurement? We will do it in the later slides, but this is how the outside jaw works. We go to the other slide. So in the last slide, which was a video, we saw that how is the yellow part, that is the vernier scale, slide. In this slide, we can see that there is a beaker, and how does the internal jaws of the vernier are kept in such a way that they are in contact with the inside part of the container or the beaker, and they can measure the width of this container. So this is how the inside jaws work. So we'll go to the next slide and we'll see the use of the strip. So we go to the next slide. So here we can see that there is a strip measuring the depth of the beaker. Now, this strip is connected to the vernier scale only. As the vernier scale slides, the strip opens. And as it goes back, the strip closes. So you can see as it is opening, you can see it is moving away from A and C jaws. So it has opened, it has come away, and so it is measuring the depth of the beaker. It can even go longer till the main scale is there. If you slide the vernier, it will go longer and longer, and then it can be closed back. So this is the use of the strip. It can measure the depth of a beaker. So you have learned that how can we measure things from the jaws and the strip. Between A and B, you can measure any coin, any length of cylinder, any diameter of cylinder. It can be measured over there. Then internal diameter of a cylinder or a beaker can be measured from C and D, and you can measure the depth of the beaker, or any thing which is having any depth can be measured over here. So these are the uses. It is also used as sextant navigator, traveling microscope. It has also been used in spectrometer. Vernier caliper has been put in some or the other way in these apparatuses also. Okay, so we go to the next slide. Now students, you have to understand this very clearly. Now this is the most important part here. To understand the divisions of vernier and main scale. The main scale divisions are the same as your normal ruler. 1 centimeter will have 10 divisions. That means one division is of 1 millimeter. Now, here we have this blue part and the white part. The blue part is the vernier and the white part is the normal main scale. Now you can see that it has the width is 1 centimeters on the main scale. Can you see? It is from 1 to 2. So 1 centimeter. The width is 1 centimeter here. And each division is of 1 millimeter. Now you can see the zero of the vernier is exactly coinciding with the 1 centimeter mark of the main scale. And the second division of the vernier is slightly before the second division of the main scale, that is 0.1 millimeter. It is slightly before 0.1 millimeter. Then the next one on the vernier is slightly even more before the 2 millimeter mark. And slowly you can see the 9th division of the main scale coincides with the 10th division of the vernier scale. That means the principle here will be applied with this only. The 9 divisions on main scale will always be equal to 10 divisions of vernier scale. That means there is a difference of 1 millimeter. And that is why it can measure even the second decimal place of any object. So now we will measure what is the least count, how is it calculated, but this is very important for you people to understand because later on we are about to talk about this only, that how does it work. So here you can see the 10 divisions on main scale is equal to 9 divisions of vernier scale. Can you see that? 10 divisions on main scale is equal to 9 divisions on main scale is equal to 10 divisions on vernier scale. Please do remember that. We are going to the next slide. So, we learnt that 9 divisions of main scale is equal to 10 divisions on vernier scale. This is in all the vernier scale. This is not one. In all the vernier scale, you will find this only, that 9 divisions of main scale will be equal to 10 divisions of vernier scale. Now, what we are here about to find, that what is the least count of vernier caliper. So, the first thing is, what is least count? Now, if you don't know what is the least count of a ruler, how will you do the measurement? If you don't know that this division is 1 millimeter, this division is 1 centimeter, this is 1.1, this is 1.2, this is 1.3, how will you measure? So that is why it is important for you to know the least count before using apparatus. So what is that least count? It is the smallest measurement that can be taken accurately with the measuring device. Now, the least count of vernier caliper, which is also known as vernier constant, is the difference between the value of one main scale division and one vernier scale division. It is the difference of the value of one main scale division and one vernier scale division. So you just have to subtract the value of one main scale division with one vernier scale division. Now one main scale division, you know, 0.1 millimeter. One vernier scale division we are about to calculate. Now let there be n divisions on vernier and it will be equal to n minus 1 divisions on main scale. Just now I said if there are 10 divisions on vernier, it will be equal to 9 divisions on the main scale. Just now we did in the last slide. So here, if there are n divisions, we are assuming that there are n divisions on the vernier scale. So n divisions on vernier scale will be equal to n minus 1 divisions on the main scale. And let that value of one main scale division is x. Suppose we don't know, and we are assuming that the value of one main scale division is x. Please take some copy because you have to calculate. Somewhere you have to write something. Without calculating, you won't understand. So what we have said is n divisions on vernier is equal to n minus 1 divisions on main scale, and value of one main scale division is x. To be taken into mind that these three things have been assumed. Okay. Value of one division on vernier will be n minus 1 into x. Yes, value of n divisions on vernier will be equal to n minus 1 divisions into x. And value of one division on vernier, we are applying unitary method, n minus 1 into x upon n. And least count, according to the definition, value of the difference of value of one main scale division and value of one vernier scale division. So x minus, and we have calculated above only, x minus n minus 1 into x upon n. And when you calculate this, you do it right now and you will get it as x upon n. The other things will cancel and you will get x upon n. So from here, we conclude that the least count of vernier will be value of one main scale division upon total number of divisions on the vernier. So if you see the previous slide, the value of one main scale division is 0.1 centimeter, and how many divisions on vernier? 10. So 0.1 centimeter divided by 10, that becomes 0.01 centimeters. So now here you got the second decimal place. This was our motive, just how to measure the second decimal place accurately, and now we have it. The second decimal place, the least count of vernier is 0.01 centimeters. Now we can easily measure the things using this. Now how to measure? We will do it in the next slides. So we move to the next slide. So in the last slide, we studied that what will be the least count of the vernier caliper. That will be x upon n. What is x? Value of one main scale reading. And what is n? Total number of divisions on the vernier scale. And normally it is x is 0.1 centimeters and n is 10. So 0.1 divided by 10, it comes to 0.01 centimeter. That is the least count of the vernier caliper normally. Okay, now here we are going to study that how to observe a reading. If something is kept between the jaws of the vernier or something, or you're measuring the depth, or you're measuring the inside width, anything, whatever you're measuring, how to read the observation. So here we are having an example of one observation. Now, you can see the above scale is a main scale and the below scale is a vernier scale. There are 10 divisions on the vernier scale. Now, when we see that the reading, the zero of the vernier is somewhere between 2 and 2.1. The above scale is in centimeters. So, the reading, that is the zero of the vernier, is somewhere in between 2 and 2.1. So main scale reading here will be 2.0 centimeter. Fine. I am saying 2.0 centimeter because the main scale can measure 0.1 place of decimal. That is why I am saying 2.0 centimeter. So main scale reading is 2.0 centimeter. Now let us come to the vernier scale reading. Now which vernier reading is coinciding with the main scale reading? One is not coinciding, 2, 3, 4, 5, 6, 7. eighth reading is coinciding. We can see that the eighth division is coinciding exactly. It is coming like a straight line with the main scale reading. Any main scale reading, we don't have to pay attention on which main scale reading it is coinciding. We just have to see which vernier reading is coinciding with the main scale. So here it is the eighth reading coinciding. So what we have to do is main scale reading plus vernier reading coinciding into least count. So least count will be 0.01 centimeter. So 2.0 centimeter plus 8 into 0.01 centimeter, and that will be the result. So what will be the result? 2 plus 0.08. So 2.08 centimeters will be the answer of this. The length which is being measured with this vernier is 2.08 centimeters. Is that okay? So we move to the next slide. Here in this slide, we are going to see that what is a zero error, and if there is a zero error, then how to take the accurate reading. Normally, if your vernier caliper is perfect, there will be no zero error. Now, what is zero error? The main scale 0 should exactly coincide with the vernier scale 0. So 0 of the main scale should be exactly coinciding with the 0 of the vernier scale when both the jaws are intact, when nothing is in between, they are very close to each other, there is no place in between. In that position, if 0 of the main scale is exactly coinciding with the 0 of the vernier scale, then there is no zero error. The vernier caliper is perfect. But sometimes it may be defective. So there are two conditions. There are two zero errors in vernier caliper, two kinds. The first one is positive zero error. Now, here, if the 0 of the vernier scale is towards the right of the 0 of the main scale, it is positive zero error. If the vernier scale reading has come beyond the 0 of the main scale, now it has crossed the 0 and it is moving further, then that is positive zero error. And if it is before the main scale 0, then that is a negative zero error. So how to measure the zero error? In case of positive zero error, the 0 of the vernier will move ahead, and whatever vernier reading will be coinciding. Suppose here we see, so which vernier reading is coinciding? I think the third reading is coinciding. So 3 into 0.01 will be the zero error with a positive sign. Please remember, signs are very important for zero error. For zero error, you have to see the sign. So here it is positive zero error because the 0 of the vernier has moved ahead and the reading coinciding exactly is 3. So 3 into 0.01. So 0.03 with a positive sign is the zero error of this vernier. So we have to keep this into mind while looking for the correct reading. We will use the zero error. Okay. Now, in case of the negative zero error, where the 0 of the vernier is before the 0 of the main scale, in that case, let us see which reading is coinciding. The 8th reading is coinciding. So here, 8 into 0.01, that becomes 0.08 with a negative sign. So here it is a negative zero error with a negative sign. So minus 0.08 centimeters will be the zero error in case of negative zero error. So we move to the next slide. So we studied about how to take the reading, how to observe the reading, and we also studied if there is a zero error, then how to measure the zero error with signs. Now we are going to see what is the complete correct procedure of taking a reading with a vernier caliper in the lab. The first thing which you have to do is to find out the least count and the zero error of the vernier caliper. You know how to find out the least count now, x upon n, and you know how to find out the zero error. If it is ahead, then what to do. If it is before, then what to do, and which reading coinciding into the least count. Now, the second thing, move the jaw J2 away from J1. The first one will be taken as J1, the second one will be taken as G2. So J2 will be slided, the vernier will be slided, and the object will to be measured will be placed between J1 and J2. Now you have to bring J2 close so that the object is intact with J1 and J2. Now when it touches J1 and J2, tighten up the screw so that the vernier scale is in the correct position. Now, next is take the main scale reading. After that, note the vernier reading coinciding. Then multiply the vernier reading coinciding into the least count. Then after that, whatever you got, main scale reading plus vernier scale reading into least count. And then if there is a zero error, then you have to subtract the zero error from this observation, and then you will get the correct reading. Okay. Now here I have given you a chart. Can you see? Serial number. Now you have to take three to four observations in the lab. Main scale reading, whatever main scale reading you will get the first time, then whatever in the second time, whatever in the third time, that you will write over here. Then which vernier reading is coinciding in each case, you will write here in the third column. Then if A is the main scale reading and B is the vernier reading coinciding, then B into least count becomes C. I have just given an example. B into least count becomes C. So in each of the vernier reading coinciding, you will get 1C. Then there will be, if there is any zero error, you will measure and you will write here with sign. And after that, A plus C minus. Why have I written plus minus zero error? Because whatever, suppose you have a positive zero error, so A plus C, it will become minus, because when you open the bracket and if it is inside, if it is plus inside, obviously it will become minus. So A plus C minus zero error. And if it is a negative zero error, so minus and minus will become plus, so zero error will be added. So A plus C plus zero error in case of negative zero error, and A plus C minus zero error in case of positive zero error. Now correct mean, I have written L, M, and suppose you get the result in first case as L, second case M, and third case N. So correct mean length of the object will be L plus M plus N upon 3. That is the average length we have to calculate, and then you will get the correct length. So we go to the next slide. Okay, so finally we have a question now. I have taken this question number 3 from your exercise only. I'll give these numericals to do as homework. Now I have done one as example for you. Now in this question, a microscope is provided with a main scale graduated with 20 divisions in 1 centimeter. So 1 centimeter has been divided into 20 divisions. And a vernier scale with 50 divisions. So vernier scale is having 50 divisions on it of length same as 49 divisions on main scale. So these 50 divisions on vernier is equal to 49 divisions on the main scale. What we have to do is we have to find out the least count of the microscope. Now we have already studied least count is equal to x upon n, where x is what? Value of one main scale division, and n is what? Total number of divisions on the vernier scale. So x will become 1 centimeter upon 20, because 1 centimeter was divided into 20 divisions. So 1 centimeter upon 20, that becomes 0.05 centimeters. And n is 50 divisions. So 0.05 upon 50, that is 0.001 centimeters. So this is the answer of this question, and very easy numericals are given over here. You can do it very easily. I'll give you a few questions also. Please write it in the copy and then learn it. I'm sure you will get the answers of each of the questions without looking here and there. If you have studied properly with the slides, you will get your answers surely. You don't have to look here and there. And still, if you have any problem, you can go through the slides again. Vernier caliper and screw gauge is very important. You have to do this in lab, so please study this properly. If you have any problem, please let me know. So, till then, take care. Bye-bye. Do the homework on your own. Don't take help from others. Okay. Bye-bye, children.